Welcome to the second of two videos where we're looking at the rules and the basics of how to solve Killer Sudoku. In this video, we're going to take a really nice example of a Killer Sudoku. We're going to go through it step by step, and by solving it, we're going to learn a lot of the basic techniques you need to solve these puzzles. So let's get going. Okay, so let's take a look together at how to solve this example Sudoku. This is one actually from 2019, but when I went back through the back archives of Daily Killer Sudoku, which is a great website and lets you do that, this was the first one I found that had examples of pretty much all of the different layout quirks that you can use to help you solve these Sudoku. So let's take a look at it together. First of all, let's take a look at how we can immediately start getting clues as to the numbers and as to solving it. Now, let's take a look at this cell here. This tells us that these two cells added together have to add up to 4. That's what the cage and the sum mean. And there's only one way that you can make 4 with two numbers that aren't the same from 1 to 9, and that's 1 and 3. So we can immediately say that has to be 1 and 3 in some combination. Now, on this site, if you select both boxes and you hit 1 and 3, then you get the little numbers in, which tells you these are the options. Now, it could be either way around. It could be 1 and 3, or it could be 3 and 1, but you know, locked in there, you've got 1 and 3. 16 is another one. 16, there's only one way of making 16 from the numbers of 7 and 9, from the numbers of 1 to 9, without repeating 8. You could have 8 and 8, but obviously you can't have 8 and 8 in the same row in the same cell, in the same square. You can, however, have 7 and 9, so that has to be a 7 and 9. We know that for sure. We can look around and maybe find some other examples of this. For example, down here, 3 can only be 1 and 2. And what you'll find is, at first these won't be obvious, but as you do a few more Sudoku, as you progress with this type of puzzle, you'll get to grips with which of these cage values and sizes can immediately give you a clue. Okay? Now the next thing we can do is actually figure out exact numbers using maths. Now, remember we said every 3 by 3 box has to add up to 45, right? Now, the site helps us with this. You see, if we start dragging over and making pink multiple cells, it will, if you have only whole cells combined, then it will actually, it helps you not cheat, but it gives you a shortcut and it gives you the sum of those cages, right? So look here, if I add that one in, then it goes, because the 10 2 pair isn't both highlighted, but if I add that one in, then it is. So here we've got complete cages again. Now, what does this tell us? Look, those 4 cages added together add up to 37, and that's 8 of the 9 cells in here, which means the difference between those 8, the sum of those 8 cells, and 45 gives us the answer for that remaining cell. So we've highlighted a cell, this one here. Now 45 minus 37 is 8, which tells us that one there is 8. Moreover, the only way you can make 12 with 8 is 4, so that's an 8-4 combination in that order. No question, we know that for sure. Okay, now this puzzle is rotationally symmetrical. If you look at the pattern, look at this pattern of cells here and look at this pattern of cells here, right? So it rotates around this center point, which means if we found a trick we can do up here, we can also do exactly the same trick down here. So add these up, they add up to 43. To make 45 total, that has to be a 2, makes that a 3. So again, we've solved here. Another way that we can use exactly the same trick, but just in a different way, is look at rows and columns. And here we've got an example where by adding up these cells, these cages, we can again find 8 out of 9. Yeah? So these 2 cages and these 2 cages added up make 43. So the odd one out has to be the difference between the sum and 45, which again is 2. Okay, so we know for sure that's 2. And this is how these two different techniques, first of all, finding cells that can only be one combination, and secondly, highlighting cells to give us the exact number. These are the starting tricks, the starting techniques to solving these killer Sudoku. Because let's look how this helps us. Now, let's take a look at this 3x3 square again. We've already got some of the answers in there. So let's look at this 7 cage. It can't contain a 1 or a 3 because we know that 1 and 3 in this 3x3 are in here. So we can get rid of any combination with 1 in and any combination with 3 in. Turns out there are only 3 ways to make 7 with these numbers. 2 of them have 1 and 3 in, or 1 or 3. So this has to be a 2-5 combination. So we've got that. Now we can 100% get this. We can get it without even doing anything clever, because look, we've got 1, 2, 3, not got a 4, got a 5, not got a 6, we've got a 7, 8, 9. So this has to be 4, 6. Okay? Don't believe me? Look at it the other way around. We've got a 1 in here and a 2 and a 3. So we can eliminate the 1 and the 2 and the 3 combinations. Has to be 4, 6. Okay? And we can start to build up a pattern of where we're looking. One of the things that comes with a bit of experience is having a rough idea from where you're at of which cells to look at next, which cages to look at next. For example, 6, a 2 pair totaling 6, you know is going to be quite a low combination because you can't have high numbers in there. It's got to have a 2 in it. Got a 2 here, so neither of these can be a 2 because you remember you can only have each number once in each row. So we can eliminate the combination with 2 in. This has to be 1, 5. Okay? Now let's look at the 10. We can eliminate the 1, 9 combo because 1's already in that row. And we can eliminate the 2, 8 combo because 2's already in that row. Yeah? Also, look in that box. 4's already there. So we can eliminate 4, 6, which means this has to be a 3, 7 combination. Now, let's look at 13. Yeah? What have we got in this row? We've got 5s and 7s already accounted for in this row, so they can't exist anywhere in these cages. So we can take the 5 combination out and the 7 combination. This has to be 4, 9. Now then, what are we missing? Well, we can look at the combinations up here. We've got 5 and 9 already in this row. 5s are there, and 9s are somewhere there. So we can take those out. So this has to be 6, 8. Okay, so just by using really simple logic, we've built up a picture already of this column, this row, I apologize, and this square. We can also start to use some of the numbers we've calculated to narrow down or clean up the combinations that we put in. For example, look here. There's a 1, 2 in this column. So this tells us if 1, 2 is here, none of these other cells here can contain a 1 or a 2. But look, here's an option of a 1 or a 5. Now, that means that cannot be 1, so that has to be 5. And therefore that has to be a 1. That helps us because look at this 9 cage that we previously put a 2 in. If we know it has to have a 2 in, we can eliminate the 1, 3, 5 because there's no 2 there. It gives us 2 options over. But this 1 means that there can't be a 1 anywhere else in this square, so we take that out. So this has to be a 2, 3, 4, and we can select those 2 cells and put 3, 4 in. But look, we've got a 4 here, so that cannot be a 4, that's a 3, and therefore that makes that a 4. And so on. We can start looking down here. Look, there's an 8 and a 4 in here. Let's look at this 20 cage. We can eliminate anything that's got 8 in. There's an 8 in that combination, and there's an 8 in that combination. And because of that 4, we can eliminate this combination. So therefore, this has to be a 5, 6, 9. Either now or later we can say, okay, 5 is definitely in this column, so 5 can't be there. So that 2, 5 is in that order. Let's look at this 12. Can't have a 5 in it because look, here we've got a 5 and a 9 already in this square. So this cannot contain a 5, so it can't be 5, 7. It can't contain a 9. So this has to be 4, 8. And again, look, we can clean up. This 4, 8 pair means in this column, the only place that 4, 8 can exist is down here. So that cannot be a 4. That has to be a 4. Now, let's look here. What are we missing? We've got 1, 2, missing a 3. We've got 4, 5, 6. We're missing a 7. So this has to be a 3, 7 pair. And we can just stick them in like that and not worry about these for the moment, because all we're doing is reminding ourselves, we've done that bit of work, we know that's a 3, 7. But look, here, there's a 7, 9 here. So these 7s mean the 7s can't exist anywhere else in this column. So that cannot be a 7, it's a 3. That cannot be a 3, therefore it's a 7. 2 pair with 3 and adding up to 9, that has to be a 6. And then let's look at our combinations. 3 cells adding up to 10, and one of them is a 7. The other ones have to be 1 and 2. We've already got a 2 here, so we'll put the 2 like that and the 1 like that. This 1 lets us clean up this pair here. Look, there's a 1 here, so that can't be a 1. That has to be a 3, and that's a 1. This 3 then cleans up this combination for us. 3 in this column means that can't be a 3, that can't be a 7. Now, what are we missing here? We've got a 1, we've got a 2, 3, got a 4, 5, 6, 7, 8. We're missing a 9, so this has to be a 9. Similarly, we can either look at this column or this square. What's missing? We've got everything except an 8, so that has to be an 8. 9 and 8 make 17. You want to make 22 total? That's a 5. You see? 5, 8, 9 combination. And so on. So let's keep going. What else can we get? Here, look, got a 7 cage. There's a 2 and a 3 already in that row. Take the 2 and the 3 out. That has to be a 1, 6. So can we get anything in this 8 cage? Yes, we can. Look, can't be a 1, 7 because of those 1s already there. Can't be a 2, 6 because we've already got the 2s and the 6s. So that has to be a 3, 5. Look, we've already got a 3 here, so that's a 5, 3 in that order. Can we get anything here? Okay, so again, looking just within this 3 by 3 square, we've already got 5 and 6. So 5 8's off the table, 6 7's off the table. This has to be a 4, 9. That tells us here, we've already got a 6 and 9 in this square, look. 6's are there, 9's are there somewhere. So it can't be 6, 9, so this has to be 7, 8. Those 8's in that row we can clear up here, 8 and 4. This 4 in turn gives us the 9 and the 4 and sets those positions. We can also start to reduce some of the options here but not solve them all together. So look, 2 6's here mean, or 6 somewhere in that cell and in this row means no 6 there. 9 means there's no 9 there. 5 means there's no 5 there. We're not quite there yet, but we will be. Now look, here's another one of these examples where we can add up 8 of the 9 cells in a cage. They all add up to 41. The total has to be 45, therefore here we have to have a 4, and that therefore has to be an 8. That's nice because that means, because we've now got an 8 guaranteed in that cell in this square, that cannot be an 8. It has to be a 6, and we can clarify those two positions. Now then, what are we missing? Got 1, 2, 3, 4, 5, 6, missing a 7 and a 9. So we could have 7 and 9 in either of those two cages, cells. However, first of all, look, we can't have 9 in that row because of that 9. But also, the other way to look at it, so let's just imagine for a second that 9 wasn't there. We're in an 8 cage. So if you need two cells, two numbers to add up to 8, obviously one of them can't be 9 because you can't have -1 in the other cell. So even if that 9 wasn't there, the sum of this cage would tell us that has to be a 7 and this has to be a 9. Just put that 9 back in. Now, if that's a 7, this has to be a 1. Okay? Here's another little trick we can play. So, a bit more advanced here. This is a cage, 2 cells that has to add up to 5. And let's just ignore that 4 for a minute. Let's just imagine that didn't exist. So, the two combinations, as you can see, that are possible, that are valid for here, are either 1 and 4 or 2 and 3. And actually, we can already solve that. Because look, here we've got a 1 and a 4 in the same row. So this can be neither 1 and 4. So even if I try to put 1, 4 in here, it can't be a 1, oh, but it can't be a 4. It's impossible for that combination to exist with both numbers already in that row. So this has to be a 2 and a 3. And look, we've got a 3 here, so that can't be a 3, that's a 2, and that has to be a 3. Just pop that 4 back in. Okay, so look here, we've got some empty cells in a cage. We know there's a 9 in this cage because, hey, we've already solved that from somewhere else. So it can't be 6, 7, 8 because that doesn't contain a 9. So here, we either need a 4, 8 or a 5, 7. Can't be 4, 8 because look, there's 4's already in there and there's an 8 already in there. So this is a 5, 7 combination. What's missing in this 3 by 3? What's missing in this row? Well, we've got 1, we've not got a 1, so we need a 1 in there somewhere. We've got a 2, 3, 4, 5, and I've got a 6, so that's a 1, 6. Okay? Can't immediately solve which position each one's go in. The 1 and the 6 goes in, but look, 1 and 6, if you want to make 9, they make 7. That has to be a 2. And don't worry, we'll come to figuring out where the 1 and the 6 are in a bit. Let's look at this 9. There's 1 and 8, a 4 and a 5. So we can take 1, 8, 4, 5 out. So that gives us 2 options, 2, 7 and 3, 6. Now, right now, we can't solve exactly how they go, but I'm sure we'll come to that and we will do in a bit. This is one of the, as Sudokus get more difficult, this is one of the challenges. You've kind of got to go round and grind and narrow down the combinations again and again and again until you find what you're looking for. Let's look at this 11 box. There's a 2 and a 3 and a 4 already in this row, look. 2, 3 and 4, in this column rather. So that cannot contain 2 or 3 or 4. So it can't be 2, 9, 3, 8 or 4, 7. So this has to be 5, 6. And look, there's a 5 here. So 5 can't be there. So that's a 6 and that's a 5. This is great because it lets us clean up down here. 5 means that can't be a 5, that's a 7. And 6 means this cell can't be 6. It's a 1 and that's a 6. This now lets us clean up here. Look, if that's a 6, that can't be a 6 and that can't be a 1. Now let's look at this 12 cage. Now look, we've already got a 5 and we've already got a 3 in this 9 by 9. So can't be a 5, 7, can't be a 3, 9, has to be a 4, 8, which is nice because it lets us clarify these and clean them up. That can't be a 4, that, oops, be a 9, that can't be an 8, and that can't be a 7. We can now figure out what's in here. Can't have 2, 3, 4, 5, 6, 8 in it, so we can just straight away say this is a 1, 7, 9. Now look, there's a 1 and a 1 here, so neither of these can be 1s. So that's a 7, 9 pair, and then that's the 1 right there. Now then, let's see where else we can solve a few. That 9 we couldn't get. Here we can eliminate the 1, 6, look. And look, yeah, 3, 4. Here means that can neither be 3 or 4, so it invalidates the 3, 4 combination. So this is a 2, 5, there's a 5 here, makes 5 and 2. That's nice because actually this clears up over here, which is really going to help us. So first of all, the 2 and the 1 are cleared up by that 2. Then the 5 being here means that can't be a 5, that has to be a 6. And we'd already eliminated some of the options here, so that can't be a 6, and that can't be a 9. So that gives us the exact positions in that cage, and that's really helpful because now look, we've got all but 2 here. So we've got 1, 2, 3, 4, 5, 6, 7. So this has to be an 8, 9. Okay. The only way of making 8 and 9 plus something making 18 is that's a 1. And then look, we can clear it further, 9 and 8. Now, what's missing in, we can look at this in two ways. We can either say what's missing in this whole 3 by 3 and get all 3, or even simpler, what's missing in that row? We've got 1, 2, oh, we're missing a 3. That has to be a 3. What are we missing in here? 1, 2, 3, 4, 5. We're missing a 6, 7. So that's a 3, 6, 7 in that order. We'll figure out where the 3 and the 7 go in just a minute. Now, again, let's try and look at the rows or columns where we're almost finished, particularly if finishing them will give us 2 of 3 or 2 of 2 of a cell of a cage. So look, I've got 1, 2, not got a 3, 4 anywhere in here. So this has to be 3, 4. You want to make 15? 3 plus 4 plus 8. So that's an 8. Look, we've got a 3 here, so that can't be a 3. So that's a 4, that's a 3. Also, this 4 and 8 clears up over here. Look, that can't be a 4. And because of the 8, and now that's 8, that can't be an 8, that's a 4. So again, we're getting closer and closer. Now, here's another nice little one. Let's look at this. Let's look at this row. We've got 1, 2, 3, 4, 5, 6, and 8. So the ones we're missing are 7 and 9. You know what? We could have told that. Because in this situation where you've got a row, or a column, or a square, where you've got a 9 set essentially, where you've got an unknown and you've got a pair, you can guarantee that the pair are the only options that can exist in there, because any others will be invalidated by the existing numbers you have. So if that's a 7, 9, that's a 7, 9. But this is again one of those situations where it's really easy to solve, because look, the cage has to add up to 9. 9 plus 0 can't work, so that has to be a 7, and that has to be a 2, which means this has to be a 9, and that has to be a 7, and then this can come across here. That can't be a 7, it's a 9, and that's a 7. Now let's finalize here. What are we missing? We've got 1, 2, 3, 4, 5. Oh, we're missing a 6. If we look at our combinations, there's only one way of making 20 that includes a 6, and that's 5, 6, 9. So here we've got a 5, 9. Look, we've already got a 5 and a 9. So 5 goes in here, 9 goes in here. And then there's one last little bit for us to clean up. This 6, 7, we've got a 6 and a 7 here. So that can't be a 6 and that can't be a 7. And we solved it. I hope you enjoyed this video, found it useful, teaching you the basic steps, how to solve a Killer Sudoku, some of those basic techniques. If you have any feedback, please feel free to give a thumbs up or leave a comment. If you enjoyed this video and would like to see more like it, please consider subscribing. As it says, we'll be posting a Killer Sudoku almost every day. Otherwise, thanks very much for your attention and have a nice day.